Hello everyone, I'm Anshul Khanna, Assistant Professor from the Department of Computer Science. I will be covering the topic ER model from Database Management System. So let us try to first understand what actually is an ER model. So whenever we design a database, there are a few phases. Like first of all, we need to gather the requirements. Then we make a conceptual design of it. We then make the logical design and finally the physical design. In the conceptual design phase, we make a high-level data model. An ER model is an example of it. In the logical design phase, this ER model is further converted into a selected data model, like we can convert it into a relational model, or we can convert it into an object model, or hierarchical or network model, depending upon what we have chosen. And finally, after this, in the physical design phase, we store the actual data and the access path, that is how we need to access it. So these are the phases of database design. ER model is a diagrammatic representation which is made at the conceptual design phase. Now this ER model stands for Entity Relationship Data Model. It is based on the concepts of entities, their attributes, and the relationships among these entities. So in this video, we will be basically covering entities, attributes, and their relationships. So let us try to understand them one by one. So first of all, what actually is an entity? An entity, if anything, is any real world object which can have physical existence or it can have conceptual existence. Like for example, a student has a physical existence. Similarly, a car has physical existence. On the other hand, department, course, bank account, these are also objects, but they do not have physical existence. But they do have conceptual existence. So an entity can be anything which has any physical existence or it has any conceptual existence. And it should be able to be uniquely identified and it should be able to distinguish from other objects. Now, any entity can be categorized into two, tangible and intangible, which I've already discussed. Tangible entities are like student, car, which have some physical existence. Intangible entities are those which do not have physical existence, like we have department, course, or bank account. In the ER diagram, we will be representing the entity with the help of a rectangle. As you can see over here, this student and car we have represented with the help of a rectangle. So entities are represented with the help of a rectangular box. Now let us discuss what is an entity type. Now all the entities, we all know that entities have certain attributes, that is they have certain properties. Now all the entities that have the common set of attributes, they belong to an entity type. For example, all the students of the university or college, they can be grouped together and placed into one entity type, that is student. Similarly, we can group all the faculty members into one group, that is one entity type, that is faculty, because the students have some common attributes. Similarly, the faculties will have some common attributes. So basically, an entity type means it is a set of all the entities that have some common set of attributes. Next is entity set. Now, at any given point of time, all the entities that will belong to that entity type, they are known as the entity set. Like you can see in the diagram over here, in the example over here, we have the roll number, name, the first name, middle name, last name, then the DOB, then maybe the branch, technical or non-technical, and gender over here. So at any given point of time, whichever entities are present in the database at that point of time, they constitute the entity set. Like we can see over here, these 5 entities, Ayushi, Saten, Nikhil, Swati, and all, they form the entity set at any given point of time. And this entity set, it is also known as extension of the entity type. Next, we have an entity instance. Now the whole thing, that means all these entities They together form the entity set. But if we take any single entity, like we have taken over here, this Satyendra, then this single entity, this is known as entity instance. The values of this will be the values of that particular entity at that point of time. So any single occurrence of an entity is known as entity instance. Next, we come to attributes. Now, each entity will have a set of attributes, that is a set of properties that will describe itself. For example, as we all know, a student, if you want to represent a student, then what all are the properties that a student can have? A student can have attributes like roll number, name, date of birth, gender, maybe branch, maybe course. All these are the attributes of a student. Similarly, if we take a faculty can have name, salary, designation, date of joining. So these can be the attributes of a faculty. So in the ER diagram, we represent attributes with the help of oval. As you can see in the diagram over here, we have student, this is an entity, and we have attributes like I've taken over your ID, then email ID and age. These are the three attributes of the student that I have taken over here. So, and attributes are the properties that an entity has. Now let us discuss the types of attributes. The attributes, they can be categorized as key attributes, multi-valued attributes, composite attributes, and derived attributes. Let us discuss them one by one. What are key attributes, first of all? Now, if we have a set of entities and we want to identify any particular entity, then we will be able to do it with the help of key attribute. So key attribute is that attribute which will help us in the unique identification of entity. Like, for example, whenever we have a list of students and I want to identify one particular student from it, then I can do it with the help of roll number, because the roll number will be unique for each and every student. The name may be common, but that particular, the key attribute will be unique for each and every student. As you can see over here, I have in the diagram over here, I have a student, and then I have few attributes of it like roll number, first name, middle name, last name, DOB, and gender. Now over here, I know that roll number can uniquely identify each student. So this will be the key attribute over in this entity. And in the ER diagram, key attributes are represented with the help of an underline. So we have the attribute and we will underline it to make it the key attribute. Next, we have multi-valued attributes. Now, any attribute which can have multiple values, that is said to be a multi-valued attribute. As you can see over here in the diagram, this student entity has an attribute phone number. Now, any particular student can have more than one phone number. Similarly, any student can have more than one hobby also. So any attribute that has more than one value is said to be a multi-valued attribute, like, for example, phone number and hobby. In the ER diagram, these are represented with the help of double oval. You can see over here, we have a double line oval. So these are multi-valued attributes. Next, we have composite attributes. Composite, any attribute which can be further categorized into sub-attributes is said to be a composite attribute. Like, for example, if I say name, I can categorize this name further into first name, middle name, and last name. So such type of attribute is said to be a composite attribute. Like, let us see in this diagram. In this diagram, I have not made name as a multi-valued, as a composite attribute, because I've written first name different, middle name different, and last name different. But I have made address over here as a composite attribute, because we all know that address can be further categorized into house number, street name, city, state, and pin code. So any attribute that we can further categorize into sub-attributes is said to be a composite attribute. And this composite attribute is represented by rounded brackets, as you can see over here. Next, we have derived attributes. Now, any attribute which can be calculated from any other attribute is said to be a derived attribute. For example, we can have age. Age can be if we know the date of birth of a particular student and we know the current date, we can calculate the age from it. We all know. I know the current date that today is so and so date, and I know what is the DOB of that particular student, so I can calculate the age. So age is said to be a derived attribute because I can actually calculate it from another attribute, that is DOB. So this derived attribute is represented in the ER diagram with the help of dotted oval. You can see over here, this is represented with the help of a dotted oval. Next, we have studied about entity. We have studied about attributes. Next, we'll study about relationship. So two or more entities, they need to be related. If we need to associate two or more entities with each other, then we make a relationship. So when two or more entity types are linked together to manage the related information, then we need relationship for it. For example, I have a student and I have a department. Now, these are two entities. These two entities need to be connected. They need to be associated with each other. So I need a relationship for it. Now, relationship is depicted in the ER diagram with the help of a diamond symbol. As you can see in the next slide over here, I have a student and I have a department entity. Now, these two entities are related to each other. We all know these are related. And I will be taking this relationship to associate the two entities. Belongs to relationship is a relationship that is associating the two entities. This entity has these attributes. This entity has these attributes. So we have discussed today what actually is an ER model. Then we discussed about what are entities. We discussed about attributes, the type of attributes, and the relationship among the entities. These are the references. Thank you.